Hello everyone, my name is Mark and I am here representing Community Circle, formerly known as RESO. That's a national nonprofit supported by Innovation and Economic and Scientific Development Canada. And I'm excited to be here today to show you around the exciting water treatment initiative that we've done for the town of Osoyoos. Just for some background, Community Circle, formerly known as RESO, did a groundwater pilot study for the town of Osoyoos from December 2023 to February of 2024. And based off the results of that groundwater pilot study, we're actually moving forward with a new surface water treatment plant drawing from Osoyoos Lake. And to achieve this, we've received engineering support from Carollo engineers, we've received equipment from Veolia, and we've also received continued support from the town of Osoyoos and UBC itself. So if you come along this way, I'll show you around the rest of the treatment. So to get started in this treatment plant, we start by drawing water from Osoyoos Lake. And as you can see over here, that wooden shed is where we have a pump, and that's bringing in lake water for the pilot plant. It's very important that we test water from the lake itself because this is the water that will eventually go to residents. So if we're using the same source to test it on, then we're going to have more accurate results. Goes through all of these pipes up into the trailer here, and this is where the first stage of treatment occurs. It's called dissolved air flotation, or DAF, and that allows us to get a lot of contaminants out. And now I'll show you how that DAF system works. Okay, so welcome to the DAF trailer. This is the start of our process. So water comes in through here, and as you can see, we have measurement equipment to assess the quality of it, the temperature, and then how cloudy the water is, and also its pH. So as the water comes in, we have two chemicals that we're using to treat the water out. The first is called a coagulant. Now this allows us to destabilize and make sure that these can come out of the water. And we have two different types that we've been using to make sure that we're picking the better one of the two. And then we also have these chemicals, it's a polymer. So after all of that is destabilized, this chemical clumps all of that together, and you'll see that later on in the process. So this combination of chemicals allows us to take out contaminants from water or that are dissolved in it, so that it can be then scraped off the top later, which I'll show you right now. Once we're done with the chemical dosing, we have a series of tanks that we're feeding the water through. This first one is a rapid mixing tank to distribute the chemicals evenly. And then we have a series of other tanks, flock tank 1 and flock tank 2. These are a gentler mixing so that the particles can really come together and form flocks. Now, what exactly is a flock? Well, we'll see it further down. So this is flock tank 2, and this is just a tank with no mixing to allow things to fall to the bottom. So what exactly is a flock? You can see over here these white particles. These are what's formed when we add that chemical. And these white particles are rising to the surface so that they can eventually, using this paddle, can be scraped off and removed from the town's water system. And how it's floating up is through this series of pipes. All of these pipes and all of this kind of craziness essentially allows us to take water, saturate it with air, and then have things rise to the top as what you saw earlier. And all of this combined allows us to get a very high quality water. Earlier, this measures the cloudiness of the water. Earlier it was at a 1, now it's at 0.19. Which is a very exciting and very good quality water control screen here that allows me to change which of the valves are open. So I can even change some of the, it's the same menu, some of the chemical dosing as well. It calculates that all for me. And what we've also started to do on site is do some simulated tests. So what I just showed over there was the full-scale DAF, and this is a jar tester that allows us to simulate the DAF process. So over here, I have an air compressor that's feeding water into here, or feeding air into here, excuse me. And then this device allows us to pipe air into each of these jars so that we can simulate the system, the full-scale system, at a smaller scale, so that we can really nail down how much chemical do we need and some of the other fine things. I might have forgotten to mention earlier, the way that these systems work is that they're using air to create bubbles, and then those bubbles rise to the surface, forming that blanket that you saw earlier and allowing all those flocks to rise up. So this is simulating that here with this air compressor and this saturator. It's a smaller scale version of what we showed in the other building. And so the second part of our treatment system after it's come there is filtration. And what do these filters do? Well, the first part was mostly for organic materials, but this will target a lot of the metals that are in water. So we have three different filter systems here. We have coal, this is coal, anthracite, just a fancy name for coal. And then we have granular activated carbon. This is actually used in a lot of Brita filters that you'd have in your home. And so this trailer allows us to figure out which of these will be the best option for the town. And the cool thing with this part of the treatment system is that it's all automated. You can see all of these valves and all of these little black and yellow things. These are all valves that are controlled automatically, and we can control those automatically using this screen over here. So as you can see here, we have a big screen showing us all the different parameters that we'd like to track, how much water is coming through, the temperature, head loss, like how clogged the filter is, and how long it's been running for. And we also can wash these filters so to make sure that they're still operating well. And then we can also measure how cloudy the water is. As you can see here, we're getting some very good screen. We're seeing some very good performance. You could see in the other building it was like 0.2. Now we're getting to 0.03. And we also have the option to dose chemicals if we want to increase the performance or disinfect the water through these pumps over here. And so eventually all of this water that's put through not just the DAF system but also the filter system is brought outside, and I'll show you how that system works now. Okay, so you may be wondering what happens to all of the water and all the waste that we're generating on site. The first thing we're doing is we are ensuring that nothing is, no contaminants, no sludge, nothing off is going into the lake. And how do we achieve that? By sending any undesirable compounds first to this tank. This tank is leading to the sanitary sewer, and it contains anything that might harm the environment. So sludge or any water that has high concentration of chemicals gets sent to sanitary sewer where it can be treated. And all the clean water is going to this tank, which is serving as another way to ensure that we're not adding or dumping anything to the environment, because this tank gives us some settling time. It allows the water to have time for anything to fall out, and it just settles at the bottom of this tank. And so it spends time in this tank before it gets discharged back to the lake through this outlet. All right, so that was the Town of Osoyoos' pilot plant for drinking water treatment. So the data that we're collecting over the next year will be used to make sure that when we build this plant at full scale, that it will give the town a safe and reliable source of drinking water. And so thank you for tuning in today, and until the next update, I will see you guys then. Is this thing on?